Hello guys, welcome back to my YouTube channel. So today we are going to be diving deep into the powerful concept of generics. So generics allows us to create flexible, reusable code that can work with different data types. So in this particular video, we'll be exploring functions as well as structs, enums, and methods that use generics and their impacts on code performance and Rust. So to get started, I'm going to demo two different scenarios with similar codes and how we could use generics to reduce or remove redundancy and make our code better and more readable. So without further ado, I'll just dive into my code editor and I'll start writing the code. So usually I would just some videos I saw on YouTube would just copy this code and paste it here. The reason I don't do that is because I believe writing out these things makes you get more familiar with them and all that. And I indulge anyone who is seeing this video to code along, and it helps. I know it certainly does help me. I know it's going to help you. So without taking much time, let me just go straight in. So the first thing I'm going to do, I'm going to create two functions, and I am going to call this function. The first one is going to be, and by the way, everything I'm talking about is in the Rust documentation. You can always go to the Rust documentation to cross-reference and all that. So I will just start. The first thing I will do is I'll create a function, and let me say, I'll create a function, and I'll call this function largest integer. And the largest integer is going to take a slice, right? So it's going to take a slice, and I'm going to call it list. So slice, I'm going to take a reference to the slice, and in that place, I'm going to pass in. I'm going to be expecting an I32, and this function is going to return I32 reference to an I32. So now I'll say let's mut largest. I'm doing this. Largest will be equal to slice, the first element in the slice. Then we're going to loop over the list. So I'm going to say for items in list. For the items in that list, I want to say if the item is greater than the largest, right? I want to equate that item to the largest, right? Else, I want to just return the largest here. So this is the first function, right? Don't worry about our main function. We'll come back to that. Now, I'm going to create another function. It's going to look through a list of characters. A list of or an array of characters, basically a slice. So I'm going to call it largest underscore chr, and it's pretty much the same function, but this time around, it's going to be a list of characters. So here, instead of passing an I32, I'll pass a character, and then I'll return reference to that. So, and once again, I'll do the same thing I did, for the first function. So I'll say let's mut close to the largest. So just want to do that to save time. I'll use my auto suggest. So I'll say for item in list. I want to still do the same thing I did previously. So I'll say for item, if the item is large, if the item is greater than the largest, I want to equate the largest to the item, else I want to return the largest. So with that, we can then go ahead and pass in those values into our function. Right now, if I save this I would get some errors if I try to run this code, right? Because these functions don't have anywhere where they are called, or we don't have anything passing to them. So let me just quickly do that and say run. So I get that error. I get that error, right? Largest integer is never used. Same for these two. So I have to declare those two functions in the entry section of our application. So the first thing I'll do is I'll remove the print hello world, and I'll say let numbers, let me just call it num, or num list. Let num list let num list be equal to a vector of some certain numbers. So I'll just say vector of 1, 2, 3, 4, 5. And after that, I will then say let the rest be equal to, so the largest, call that largest integer function, and I'll pass the reference to the num list to it. Right, so this is for the first one. Then at the end, I would do a kind of a print line, and my print line, I will just do something simple. I'll say the largest number should be blah blah blah. So I'll say this is the largest number. This is the largest number. Space. Then I'll just copy this and do similar thing for the other function. So here I'll call it largest, okay, num characters on char list, and in that place I'll pass in some values. I'll say a, then I'll pass in the similar to what we just did, so there's no much difference. So character is, I'll say the largest character. So I'll save this, and then so now I'm just going to quickly run this code so that we'll be able to see what would happen here. Basically, we are looking for the largest character and the largest number, and that's what we are going to get. So I'll just go ahead and do that. So I'll say go run. Okay. So I'm getting some errors here. Mismatched type. Okay. So first of all, on line 7, I have a mismatched type. Argument to this function are incorrect. Okay, largest integer. So my largest integer is supposed to get. Okay, so I've seen the issue. So I'm calling that function twice, and that's why I'm getting the mismatched type. So what I would do here is I would change this to largest character, and this would fix the two bugs that we are facing. So I will just say largest character, save this, and run it again. Say carry run. Yeah, so you can see that we now have the greatest number, which is 5 in our. So I'll close this a little bit, and I'll clear my terminal. Now run it again. So you can see we have 5 and F. So the largest number here is 5, while largest character here is F. But with this, you can already see that both functions are doing the same thing, but for different types, right? We can eliminate this redundancy with the help of generics in Rust. So I am just going to quickly go ahead and you know write some code that is going to kind of explain how this works. So the first thing I'll do is I will comment out these two functions. And I'll try to write a generic function that would accept two types and still do the same thing. So I'll comment this out, and on top of that, I'll say I'll just call it largest. I'll say fn. I'll say largest. So let's pass in t. Yeah. And then I would pass my list. So I'll call it list list. And that list, I'm now going to do the same thing I've been doing. So I'll pass the reference to the generic. So I'll say let's do this. And I want to return whatever generic it is, which is t. So inside here now is basically the same thing from what we had done before. So I will just go ahead and copy what I have here. So I will not waste much time and paste it here and remove the comments. Okay, so save this. So if you notice what we did here, we used it to constrain t, right? We use it to constrain t to types that can be ordered, enabling comparison within the function. So once again, if I save this and I run this code, okay, I'm getting largest character. Okay, so the issue here is so the reason I'm leaving all these bugs is so that you see how I debug. It's not like it's magic or and one doesn't make mistakes, right? We're all still learning. I'm still learning. Everyone is learning. No one knows it all. But basically, what's happened here is I forgot to change from the functions I commented out to this generic function which I named largest. So that's what I'm going to do now. So I'm just going to delete this, save, and I would run this again. And you see that using one function now, we've been able to further simplify our code from having two large functions into having just one function that does the same thing, like the same thing the previous two different functions did. So now we are going to see how to implement generics for structs. If you've watched my previous videos, I would link in the comment section. Sorry, in the description. I've talked about structs in some other videos. I'm also going to put a link to the documentation in case you want to like go further into it. But basically, we are going to look at how we can apply generics to structs. First of all, I would comment out everything here. So here, we declare a struct in Rust. So we use the struct keyword. So say struct, and that struct would say, in this case, we want to call it point. So notice the capital letter, and in order for us to use, okay, so we just say this, and we can just declare it like this, right? But in order for us to use a generic, we can go ahead to add that generic type to some places in the struct. But originally or basically the way it is being done is we are now going to go ahead and say, okay, fine. So this is since this is a struct point, we can say this is X, and we can say we are expecting an I32 here, right? And at Y, we're also expecting an I32. Like this is how we basically declare a struct. But if we want this our struct to be used by multiple, to be generic, right? Would go ahead and replace that. But first of all, the first thing we'll do is we'll pass T. And if you wonder why I'm using T, is because T is a general convention for Rustaceans. Like everybody uses T, so why will I use something different? So I'll just replace the I32s with T's. So this is the first. This is how. So with this, we've implemented generics for structs, right? So the next thing I'll do is I'm going to create another main function. So edit function main, and so here I'm going to say let's integer. So I'll call it integer equals to. So I'll call my point struct point, and here I'll say x is 1 and x is 2. Let me just use the suggestion from VS Code. And I can also go ahead and say let's float, right? So I can create a float, and I would say point to where x is 2.0, 2.9, and y is 3.5, right? So in the previous time when I declared the struct, I used f and 130 I32s. This would have not been possible, right? But now that I've changed it to use the generics, it is now possible for me to go ahead and pass in different values using one particular struct because of generics. So this is one way to do it. You might be thinking, what if you want to pass in both um, a float and an integer, right, to the struct? That is also possible, right? And the way we do it is we have another convention, and we have another way, not the convention, we have another way of doing that. I'm going to use a different struct for that. So I'm going to say struct, call it direction, right? And I'm going to pass in the t. And since I know I want this struct to have multiple values, right? I'm going to pass another generic into that place, and I'm going to call it u. U is also a convention that is usually used by Rust engineers. So then I would go ahead and close this, and I will say x would be equals to t, and y would be equals to u. So now we can then let me use this same um, main function. So I'll just cut it and place it down here. Inside that function, I'm going to say let int underscore float, let it equals to, I'll say direction, and in that direction I would say x is 1 while y is 2.9. I'll just do it like this, and I would save. This is just how you can pass two different types into a struct by passing the t and the u generic basically, um, so that it enables it to accept different types. Then the next thing we are going to look at is how to use structs with enum definitions. So enum also has the power of leveraging generics. So comment this out again, and yep. So here I would say how to declare, like creating an enum is similar to how I created a struct option, and in order to use generic we pass t, very similar syntax to the way we did struct, but here the option enum has two values, which is the sum and the none. So the sum, so it's a sum value, pass t, and the none takes nothing, right? So we just say none. That's that. And also we have for the results, say enum, and we have a result. So the result has two things: the OK and the error. You can usually use this from when you want to make an API call to handle success and error states. So we can say this. Go ahead and pass the T and the E, right? And here we would say in a bracket, pass that T and do the same thing for the E, right? So this is the results enum and how you can implement generics for it. And this is the options enum, how you can implement generics for it. So the next thing we are going to look at now would have to be how generics works with method definitions. So methods can use generics too. So we'll go back to our point structs and see how we can implement a method on our point struct. So we all know that structs are kind of similar to OOP in object-oriented language. If you're coming from a language that has some OOP to it, you understand what I mean. So you can you can like implement a method on a struct that does a specific thing. So I'm just going to comment this out and also comment this out in case I have to use it. I might not use it. What I'm going to do here is I'm going to create an implementation block. And in this implementation block, I am going to be making use of making use of generics to write a function that does something, right? So the first thing I'll do is I'll use the impl keyword, and with the impl keyword, I would first of all pass a generic which I'll call t, and after that I'll say point because I want point struct. So point and t again, and after that, so this is just us like you know using generics in method definition. So I'm going to write a function and I'll call that function x. So I'll say function fn x, and this fnx is going to talk to itself. So I'll say and self self. I'm going to return e, and then self.x. Right. So in my main function here, let me say print save, clear on my code. Yeah, so we have px is equals to 1. See how we are getting, we wrote like a method that is using generic type on the struct itself, which is the point struct. So we can also like constrain methods to specific types. So for instance, an F32, an I32, a U8 or something like that. So, a string or something like that. So in this case, I'm going to constrain a particular method to a specific type. In this case, it's going to be an I32. So I'm going to write another implementation. So I'll say here, say impl, and in this implementation, I am not going to pass the generic t. Right, I'll just go ahead and write out the point. So say point. So because I want it to be attached to a specific type, I'm going to pass that specific type here. So in this case, I'm going to say, let me pass it to let's do an F32. Then I'll close my brackets. Then I'll go ahead and write my function. So this is how we can constrain methods to a specific type. So in this case, we know that this particular method is going to accept only F32. So if I try to run this, I'm going to run this with the floats instead. So I'll say instead of it running into the integer, I'll run into the float dot distance from original. So run this. So I get 38.31. I get that value there. That's all for implementing generics for structs, enums, creating a method constraint, and creating a general function that uses a generic like we have here. I'm going to talk about why this is even important in the first place. So, generics in Rust are efficient due to something we call monomorphization. I recently tweeted something on my Twitter where I was asking some certain questions about monomorphization, and I'm going to attach that tweet somewhere at the top of this video. But basically, the monomorphization is the process that converts generic code into specific codes for each type that is used, ensuring that there is no runtime cost. One thing to note about this is that it is done during compile time. So we're going to quickly explore what this monomorphization, we're going to explore what this monomorphization is. I'm going to use the code I'd written before to give a detailed example of what it is. So now, getting back to this place, I'm going to just go ahead and uncomment everything that I had written. Comment this. Okay. So I would also then I would comment this out because I'm no longer using them. Then I would reduce this because I'm mainly explaining at this point. So we have our main function, we have the one we had written before, that is the generic function, and we have the ones we wrote for two of the different cases that we are trying to handle. So when the Rust compiler sees a call to the largest function with specific types for I32 and the character, it generates a kind of a concrete version of the largest for each of the types. So it goes ahead to generate code for each of the types that were passed into this generic function, right? So the first thing it does is it does what we did here initially. So it creates a function for I32. So I'll just say oh, I32, and it creates another one for the character. Creates another one for the character. So these functions are then compiled into the final binary of our code. So why Rust does this is that it does this to ensure that each generated function is optimized for a specific type and there is no runtime overhead associated with generic functions, right? So this is done when we are compiling our code, so it um, doesn't affect our code in runtime. So what are the benefits of this monomorphization? So number one is performance. So at the end of the day, the resulting code is faster, and it looks like we manually wrote each of the different types just like we did in the beginning. So it makes it's faster, just like as if we wrote it from scratch because of the process of monomorphization. Another thing again is that type safety, right? So type safety, all type checks are done at compile time in Rust. So we are sure that so this reduces the chances of type related errors in our code, right? Then another thing again is code reusability. So you can write a function once and use it anywhere. So, but this does not mean that it doesn't have some drawbacks. It has some drawbacks. And one of the drawbacks of this is that our code is bloated and it also affects the compilation time. So monophomization is a powerful feature in Rust that combines the flexibility of generics with the performance of manually specialized code. By generating specific versions of generic code at compile time, Rust ensures that you get the best of both worlds: reusable code with high performance. So this one thing to note is that this process is highly invisible to the programmer, but understanding it would help you to write better code and also appreciate the language Rust itself. So I think with this, I've come to the end of this video. Generics in Rust is very powerful, in my opinion. It helps us to write reusable, flexible, and efficient code. And by understanding how to apply them in our functions, structs, enums, and method, you can significantly up your Rust game. So thank you so much for joining me on this one, and I will see you in the next one. Bye.